Hi all, welcome back to the channel. In today's video, we're going to be learning how to write ionic chemical formula and working through examples. When it comes to writing ionic chemical formula, it helps a great deal if you already know these things. You have to know the difference between cation and anion. This also means knowing the symbols for cations and anions. 2. You need to know that ionic compounds have a net charge of 0. This means that the total positive charge is equal to the total negative charge. With that being said, let us get to writing the chemical formula for ionic compounds. For illustration purposes, we're going to use the compound calcium oxide. The very first thing you want to do when given the chemical name of an ionic compound is write down the symbols of the cation and anion, that is, the metal and non-metal respectively. In the given compound, calcium is the metal and has a chemical symbol Ca, and oxide, which is the non-metal, has a chemical formula O. Following which, determine the charges of the ions based on the elements group on the periodic table. Calcium is a group 2 element and thus has a charge of +2. As a result, it will be written as Ca2+. Oxygen is a group 6, or some think of this as group 16. Either way, elements in this group form ions with -2 charge. Thus, oxide is going to be written as O2-. To obtain the chemical formula, we cross-multiply the charges. This means that the charge from the anion becomes the subscript for the cation and vice versa. So, we write Ca2+ on one side, O2- on another side, and carry out the cross multiplication. Doing a cross multiplication of charges, the subscript of calcium becomes 2, and the subscript for oxide becomes 2 as well. Therefore, theoretically, the formula can be written as Ca2O2. This means that the charges balances out and the sum of the cation is equal to the sum of the anion. This is because you have a total of 2 cations and a total of 2 anions. Although the formula can theoretically be written as Ca2O2, however, in ionic compound, we make use of the lowest whole number ratio when writing chemical formula. Essentially, this means that Ca2O2 can be further reduced to CaO. Okay, let us look at another compound where the ratio of ions are not as obvious. Write the chemical formula for magnesium chloride. Magnesium has a symbol of Mg and as a group 2 metal has a charge of +2. Thus, it will be written as Mg2+. On the other hand, chloride has a symbol of Cl and as a group 7 metal has a charge of -1. Thus, the ion is written as Cl-1. Again, to obtain the chemical formula, you do a cross multiplication of the charges. So, Mg2+ on one side and Cl- on the other side. And you carry out the cross multiplication and obtain the subscript of each of the ions. Thus, the chemical formula can be written as MgCl2. However, how do you know if your answer is right? To do so, you check that your overall charge is balanced. That is, the total charge of a cation equals the total charge of the anion. To determine the total charge of magnesium, you take the total number of magnesium you have based on the chemical formula, which is 1, multiplied by the charge of magnesium, which is +2, and this is equal to +2. To determine the total charge of chloride, you take the total number of chloride that you have based on the chemical formula, which is 2, multiplied by the charge of chloride, which is -1, and you get -2. Based on this, you can see that the overall charge of the cation is equal to the overall charge of the anion because magnesium has an overall charge of +2 and chloride has an overall charge of -2. Thus, the chemical formula MgCl2 has a balanced overall charge. Let us look at one last example, barium sulfate. Barium is a group 2 metal and has a symbol Ba with a +2 charge. This means that it will be written as Ba2+. Phosphate is a polyatomic anion with a symbol PO4 and a -3 charge. Thus, it will be written as PO4 3-. In order to obtain the chemical formula, we cross multiply. So Ba2+ written on one side and PO4 3- written on the other side. We carry out the cross multiplication, and from this we obtain Ba3 parenthesis PO4 close parenthesis 2. Take note that you put the parenthesis as the 2 applies to the entire phosphate. With that, we've come to the end of today's video. If you need more practices on writing chemical formula for ionic compound, you can head to the description box and click the link to download practice problem as well as detailed solution to each question for free. I hope you enjoyed today's video. If you have any question or need clarification on anything discussed today, you can utilize the comment section or send me an email directly. Additionally, if you do require more assistance on chemistry and someone to thoroughly guide you through the concepts or practice problem, we do offer one-on-one tutoring sessions. If you believe you will benefit from a one-on-one tutoring session, you can go ahead and schedule an appointment. You can find the link in the description box. Have a good day and see you in the next video.